All right.
Wait, so today a hard day?
Today is more of a challenging day, yes.
Tomorrow's easy?
Tomorrow will be easy and then somewhat easy.
You say there's gonna be people gone tomorrow?
Yeah, youth and government is gone.
Wait.
I know there are a few in here, but like the next class, the next trig class, there's 11 of them gone. Yeah, so there's just like a couple in here that are gone tomorrow, but my other ones, over half. So, okay. Yesterday your story problems involved angle of elevation and angle of depression. We talked about that. Today the story problems are going to talk about bearings.
Wait, what'd you just say?
Wait, what's youth and government tomorrow?
Youth and government's gone tomorrow to Marquette.
Oh.
Nope, it came through as youth and government is fixed.
Oh.
The NMU thing was like a year ago.
Like, wait,
What?
All day.
tomorrow?
How do you not know this?
Well, I mean, it was like a month ago.
Because I can't go to any meetings.
Oh, you're gone tomorrow all day.
Oh.
I knew you were on it, and there was a couple in here on it. Like I said, fifth hour, there's a lot. Okay, back to this. Let's focus.
Justin as president. I don't know.
I don't really know how I feel about that.
Oh, God.
That makes me kind of nervous. I don't really know.
Okay, a bearing is a navigational angle measure. If you are a pilot or you are of an airplane or a ship, the direction you're going in will be given as a bearing. Okay, so that's why we call them navigational angle measures. They are measured from
You are not a plane.
due north clockwise. So your bearings will go from 0 degrees all the way back around to 360. Yes. So why did I put the rounded bracket on the 360? Because it means it's not included.
Because you can go past it.
Can I equal it?
Yes.
Not according to my bracket. Why shouldn't I equal 360? Because it's the same as 0. So there's no sense in having both of them. I'm either at a 0 degree bearing, but 360 is the same place, so that's why we put the not include the 360.
You can go up to 360.
Yes, up to 360. So you always measure from due north. So due north is your reference line. I always dot in the reference line. And then we measure the degree measure going clockwise. So that angle measure is your bearing. Always a reference line from due north. So before we get to the story problems, can you name? Yeah, you guys need to stop talking. Name the bearing of each point. So we're talking about a coordinate plane. Austin.
Is this where we add the extra stuff to the circle? Is this that part?
No, let's not get ahead for now.
Yeah, I don't know what you're talking about yet.
Yep, we let her speak.
Okay. So we're going to put a point on a coordinate plane, and you're going to give me the bearing of the point. So the first point I'm going to give you is the point 30. So if you were to plot that point 30, where would you be at?
In the x-axis.
I would be on the x-axis. 1, 2, 3. Okay. I want to know what bearing that is at. So I need to know how far from due north, because that's my 0, do I have to turn to get to that point?
90 degrees.
Agree that's 90 degrees? So the bearing of the point 30 is 90 degree bearing. So it's how far from north, rotating clockwise, to get to that point.
Okay.
All right. How about, let's go negative 6, 0. Well, let's just say that's negative 6. Close enough. So how far from due north is it around to that? 270 is its bearing. Okay, let me challenge you. Okay, 270. So from the north, how much is this?
90.
How much is this?
180.
180.
So 270.
Yep.
Will it always be like a?
Nope, here's your challenge.
Oh.
Let's go
You know, I figured you'd throw something.
negative 2, negative 2. It will be something you can figure out, though.
What if I don't want it?
Okay, negative 2, negative 2. I'll even draw a little ray through it for you.
Wait, I may or may not know the answer.
Oh, you may or may not know this.
I got it, Mr. Schwartz.
Kenley, what is it?
Okay, so you're gonna go all the way to the 180.
Very good.
Right, and then you go 45 more degrees, and then you got your answer.
Why 45 more degrees?
Because the 90 is split in half, so that's
She is correct.
What if you're not split in half, though?
I won't give you one like that.
Okay, fair enough.
Will there be one on the homework like that?
Probably.
It's so easy in that case.
Because you can think about it, this triangle, if I make a triangle here, how long is each side on this triangle? The legs?
2.
2 and 2. What kind of right triangle has legs that are the same?
45.
You're 45, 45. So what's 180 plus 45? 225? Okay, so you can find bearings of points. Let's do some story problems that have bearings in them. About the same as yesterday. Okay, so we got to write the problem. Okay, number 10.
That's example 2.
Oh, it is.
It sure is.
It's our first story problem, though. That's why I put a 1 there.
Wait, why is today in there for?
All right.
Again, I'm not smart enough,
Okay. 2 lighthouses. Are located on the same north-south line. So one is directly north of the other one, or one is directly south of the other one. From Lighthouse A, I'll use LH for Lighthouse A, the bearing of a ship
I get it.
3,742 meters away is 129 degrees. Yeah, this one's long. 43 minutes. From Lighthouse A. So I'm giving you the bearing of a ship and telling you how far away it is, with your reference being Lighthouse A.
Why do you have to throw degrees and minutes in there?
I know. From Lighthouse B, the bearing and distance to the same ship are 39 degrees 43 minutes, and distance, don't know the distance, I lied, the bearing. Find the distance between the lighthouses. There, that was a long one. Find distance from Lighthouse A to Lighthouse B. Okay, I'll give you time to write that all down.
You wanted to not have the distance?
Nope, I thought it was in here, but it's not.
draw it.
Absolutely.
Good call, Kenny.
Thanks.
I'm kind of wrong.
I know. I thought I had both, but I see it's not.
The bearing to the same ship.
Yep.
are.
Well, that's because it was supposed to be two things. It was supposed to be bearing and distance, but then distance went away. And just didn't change my verb.
It's a verb.
Yeah.
It's an adverb.
Linking verb.
Oh.
That's what they called them back when I was in elementary school.
I never got all that stuff.
Is, and are. There's only three of them, right? Linking verbs?
They just kind of,
I think that's the problem.
here, read this worksheet.
Okay. Are you ready? What do you think would be the best thing to start with when you're going to draw this picture?
Lighthouse A and Lighthouse B.
Probably not.
The triangle. The line.
No.
And then
Which line?
north, south.
I would definitely start with a north-south line.
That's what I meant.
Alright.
If I was to just throw A and B on here,
Well, I meant the line. I always thought the ship was that long. Your line looks like a ruler line. Ooh, mine does.
okay,
too.
Speaking of rulers.
so I've got my two lighthouses, but I don't know which one's north of the other one yet. So I'm not going to label A and B yet. Okay. So if I am at A and I'm looking to the ship, I need to turn 120, about 130 degrees. So I could be here, and I turn 130, that's about here. Okay? If I'm down here, it's still in the same, it's down here. If I'm at B, I've only got to turn about 40 degrees. So, this or this, what's going to make the two intersect? They have to see the same.
A on top, B on bottom.
Okay, you saw it, you had vision. A on top, B on bottom. So now let's go back. From A, I want to rotate about 130 degrees. So that's about here. So I'm going to swing around. I'm going to show my rotation from north, because this is a north line. I want to show the rotation around. And somewhere along this line of sight is going to be this ship.
Where's the 90?
The north. This is a north-south line. And I'm doing a bearing, just like the coordinate plane. This is like my origin here. Yes?
So why does it say start at A?
Because this is an ordered pair. Just like when we did these here,
I'm gonna fail this.
you always have to start the rotation above, face north, and then rotate around. So I'm just starting the arrow above it. You always do that. You can't start on the point and turn.
Okay.
It's impossible. You got to be above it.
Okay.
So you got to face north and then turn.
Why is 130 degrees right there?
Just estimating.
Yeah, but
I know what 90 is.
that's 90?
All right, directly to
Oh,
my.
I see it. I see it.
Okay. Just estimating what about 130 degrees is. Okay. From lighthouse B, I want to turn about 40 degrees. So again, I want to start north of it, facing north, and then turn. So I show that rotation. I always start the rotation above the point, and then turn. You always want to show your rotation and label the angle so it's in the right spot in your picture. This one's 39 degrees, 43 minutes. So where those two intersect is the ship. Ship. Okay. We can't go by what it looks like. So we may not have been very. What else? What other number can I put in here?
The distance between A and ship.
From A to the ship, they gave me that distance. So that's this side of the triangle, 37, 42. Our goal is to find the distance between the two lighthouses. I can do SOHCAHTOA if I've got a right triangle. I have to be able to verify where the right, you will always have a right angle. Can I find the right angle?
Draw a line from the ship to the north south line.
So, could I find this angle here? How?
Yeah.
180 minus 120.
Yeah, those two have to make a 180. So if you do 180 minus that, see what we get here.
those two are like the initial two angles not supposed to be going.
I'm going to subtract this from 180 to see what this angle is in here.
I think the 45 is where the ship is.
The 90, you mean?
Yeah,
Yeah.
that's what I meant to say. Because the way I drew it is perfect.
43 minutes. So the angle in there is 50 degrees, 17 minutes. What would I do now to find the third angle? How do I get this angle at the ship? Austin?
You add those two together.
Add those two together. And what am I hoping they add up to? 90, because that would leave 90 here. So if I add 39, 43, oh, if those two add up to 90, this is a 90 here. Okay. Now it should be easy. So I can either stand at B or I can stand at A, because I know both angles. Which one do you prefer to stand at?
A.
All right, Austin called A.
I have a question.
Yes.
How did you come to the assumption that that angle up there was a 90 degree?
Because I added these two together, because I know the three angles of any triangle have to add up to 180. So when I added these two together, I got 90. 180 minus 90 leaves me with another 90. Okay. So, standing at A, I know the 3742. What side is that if I'm standing at A?
Adjacent.
Adjacent. What side am I trying to find?
Hypotenuse.
That is the hypotenuse, since it's across from the 90. So which trig function? Cosine. CAH. So it's the cosine of what angle? Yes?
We're looking at this from the A.
Yes, our reference was the A, because Austin picked A. So my A angle is the 5017. Let's see, adjacent is the 3742 over the hypotenuse. And now you should be able to see what to do with the calculator. And go ahead, get me an answer. And we've got 4 sig figs. $58, $56. And that would be very good. Any questions? Oh yeah, I held your hand right through it all. They're easy when I hold your hand. Super easy when I hold your hand. Okay, let's try another. I'll try to shorten up the wordiness of them. That would be example 3. Let's see, we've got a plane that flies 1.3 hours at 110 miles per hour on a 40-degree bearing. Oh, no minutes. 40-degree bearing. Now it's going to turn and fly 1.5 hours at 110 miles per hour on a 130-degree bearing. How far is the plane from the starting point? From start, yeah, it's technically, it would make a nice, we're going to assume a sharp turn.
Turns on
Okay. I don't know which direction this picture is going to grow in, so make sure you come down far enough on your paper for this picture to grow up, just in case. It might go down and we'll have a space on our nose, but I don't know. Well, I know, but just helping you out. Leave some space for this picture to grow north. All right, so I'm going to start at my starting point. Here's my plane on the start. So I want to draw the first leg of this flight. Anytime you see the word bearing, I want to see a north reference line, because we always measure from the north, and I always dot in the reference line. So I know it's not really a part of my picture, but it'll help me with the angles. So I want a north starting line reference. And I dot it because it's not actually part of my triangle. So I want to fly on a bearing of 40 degrees. So what does that mean? From the north, I want to rotate over about 40 degrees, and I'm going to fly. So now I'm just going to show the rotation. Austin, I started above, 40 degrees, and here I go. Label everything. Now I'm going to turn. Oh wait, what do I know about this leg of my trip? I went for 1.3 hours at 110 miles per hour. What is that going to help me with? 1.3 hours at 110 miles per hour. What can I figure out knowing those two pieces of information, physics people? The distance. How do I get the distance?
Times, multiply that.
Yep, multiply that. What is 1.3 times 110? What is it? 143. And technically, this is 2 sig figs on both of these numbers. So if we did 2 sig figs, what would it be? 140. Yep, multiplying them and rounding the answer to 2 sig figs. If you use 143, I'm not going to mark that wrong. Okay.
I already have one physics class.
Okay. So now I'm here, I've got to turn. And I'm turning on another bearing. So what should I start with? A north line. I've got to do another bearing from here, so I need another north line. Did I not tell you to leave this thing room to grow north?
I did, but not that much room.
Oh, well.
I did a lot.
Okay. Now I want to turn from that north line 130 degrees. So from here, 130. So show that rotation. There's the 90. I'm going to go past that about, just guessing, that much. There it goes. And this one's going to be longer in reference, but that's okay. So that rotation was 130 degrees. Can I figure out how long this distance was? By doing?
I did 1.5 by 110 miles per hour.
By 110, and rounding to 2 sig figs gives us what? 160? Okay. And then we want to know how far we are from the start.
Can we check that? Probably not. It's 165. Wait,
Yeah.
So it would be 170 then.
So we create a right triangle.
Hopefully we've got a right triangle in here.
We don't.
Okay. The angle we're going to find, this is not necessarily straight across. So we can't assume that there's a 90 here. But the angle we can find is the one up here. If I extend this line down, this north-south line, I will be able to find both of these pieces and add them together. So, how do I get this part of my angle?
Subtract 130.
That should be 180 with that, correct? So what is this side of the angle?
50.
50. Easy number to work with. How can I get the other side of this angle?
Opposite.
Not opposite. What are they called?
Sounds like a complementary supplement.
Parallel. Do you agree that these two dotted lines are parallel?
Yeah.
And this is a transversal cutting through here?
Wasn't back.
Opposite.
Alternate
Alternate
interior. Oh, you guys are killing me. Alternate interior is the 40 transfers
I know
in.
what we were doing though.
Okay. alternate interiors. So here's our 90 right here. Yeah. Okay. So, my goal is to find this side of the triangle. Do I need SOHCAHTOA to do that?
Yep.
Nope. Why not? I know this side's 140. I know this side's 170. How hard is it to find this side? This is the knowing this is the hypotenuse, I can set up a Pythagorean theorem now. So I don't even need trig. So it's 140 squared plus 170 squared equals, I know x is going to be the hypotenuse, so that's by itself over there. Now it's just a simple Pythagorean theorem. I got to see what I assigned here. 2 sig figs. 220?
Yep.
220. Very good. Okay, I need to see if we got to do one more here. Trig. Tuesday.
Like, we have to do stuff like this on our own.
1, 3, 4, 8, 9, 11. Oh, 11. Yep, we got to do one more thing. Sorry, just hold on, one more thing. Okay, now that you're good at those bearings,
It's gonna get tricky now.
nope, there is an alternate bearing system.
Is this another one? Was this like a long one?
Nope, short. Okay, normal bearings are measured from the north clockwise. There is an alternate bearing system, which measures from north or south going east or west. Draw each bearing. Okay, you might see bearings written like this: north 40 degrees west. What do you think my reference line is here? The north. The north is my reference, so I dot in the north. What do you think the 40 degrees west means?
You go to the left.
You're going that counterclockwise toward the west 40 degrees. So I'm going to swing this way 40 degrees, and then there I am. So they give you a reference line and then a bearing with a direction. So if I had south 15 degrees east, could you draw that?
Going down.
Yep, our reference line is south this time, so I dot in a south line. South. And if I want to go 15 degrees toward the east, from there, which direction am I going?
Right.
To the right. To the right 15 degrees. Because my east is over here. So is that easy enough to understand? Your first one's your reference, and then east and west is your which way you're swinging. So we'll do one story problem with this kind of notation in it, and we'll be done.
This is example 5.
Yes, it would be. Today took a little bit of time.
Or then Katie.
So, how much room would you
I don't even know because I closed my book. Let's see. Oh, it doesn't. It's much smaller than the other one.
So we're done, right?
Hold on. I'm gonna do this one. I'm not gonna give you as many as I was going to. We'll do more in class tomorrow. So that's all good. Oh yeah. Right now. Hold on. Patience. 14. There we are. Okay. Oh, we're traveling in Georgia here. The bearing. From Atlanta to Macon. Atlanta, Georgia to Macon. Georgia is south 27 degrees east.
Where's the straight road?
The bearing from Macon to Augusta dittos means it's the same as above is north 63 degrees east. Let's see, an automobile traveling at 60 miles per hour needs 1.25 hours to go from Atlanta to Macon. So we're going to say, can I stick it on the end here? 1.25 hours at 60 miles per hour. And the other one is 1.75 hours. So that's 1.75 hours at 60. Can you find the distance from Atlanta to Augusta?
No.
Atlanta to Augusta distance. Okay. Leave lots of room. Come down on your paper. Okay, I got to start somewhere. What city am I going to start in? Atlanta. So I want to go from Atlanta to Macon. So here's Atlanta.
Are we doing south?
Okay. So from the south, I want to go 27 degrees east. So what should I start with? A south reference line. So I'm going to dot the south line. Now I want to show the 27-degree rotation. Which way is it going? To the right, 27 degrees. Show where the 27 is at. So if I stop here, where am I at?
You're at
Macon.
yeah.
Can you get me the distance between those two?
No. Yes.
Yes.
Yes, I can.
1.25 hours at 60 miles per hour is what? 75? I'm going to say that 60 miles per hour is exact. That was my guess because I know they didn't use 70 or 80 there. Okay. Now, the second part is from Macon to Augusta. Where am I standing at? Which town am I in? If I want to go from Macon to Augusta. I'm going to stand in Macon. Where's my reference line going to be if I know the bearing is north 63 degrees east? So from Macon, I want a north reference line. Show the rotation, the 63-degree rotation. And this is farther, correct?
Yeah, so I did too, so
Oh.
all this stuff is at the very bottom.
Sorry. I thought it grew north, but I see no, it doesn't. What's this distance? Anybody do it yet? 105? And this is Augusta over here. And our goal is to find out how far apart they are.
I need to redraw this whole thing.
Okay, can we verify where the right angle is at?
No.
Yes.
It's
I,
right there.
why, how do I know this side of the angle?
It's 63.
That's 63. What's the other side here?
It's 27,
Why?
because it's alternate.
Alternate interior. This 27, because you got your parallel lines, this 27 transfers over here. And what is 27 and 63?
90.
Oh, nice.
Good job, Ed.
Now I know that x is on the hypotenuse of a right triangle. It's a little Pythagorean theorem. I'll use the space above since I have so much of it. Okay, you guys do that. I'm going to shorten up the assignment for homework. I'm just going to give you a few of them, and then tomorrow we'll put everything together. Okay. These are not all story problems. Let's go. We'll do these ones. Page 99. 1, 4, and some story problems. Let's go 8, 9, 11. Let's just try 3 of them. 8, 9, and 11. I think it's 3 sig figs actually. 2? Where's the 2 coming from? But I think that's exact. Yep.
2 or 3?
They're going with 3 on the book. Because there were 3 on my, because the 60 miles per hour is exact, there's 3 here. We should have written this as 75.0. And we didn't. Okay, so you have, these 2 are super easy, and then these 3 are story problems.
Oh, wait.
So I only gave 1, 4, 8, 9, 11. Okay, stop.